Hello, beautifuls. This is Atleen, and I'm coming to you with a video on IPv4 subnetting overview. This is part 3, and we will be working out of the CCNA 200-301 book, and this is volume 2. Wendell Odom is the author, and we will be discussing analyzing classful IPv4 networks, chapter 12. And after we read, we will go over Do I Know This Already? Quiz. And it has 1 through 6, 1 through 5. And Do I Know This Already? So let's begin to read. And the topic that we're doing today is the unusual network IDs and network broadcast addresses, meaning that some of the numbers will be a bit different, and a little bit unusual, so it could be a little trickery on the CCNA 200-301 exam. So this is why I'm going over this topic today. Okay, so I'll start to read. For some of the more unusual numbers, in and around the range of Class A, B, and C network, numbers can cause some confusion. This section lists some examples of numbers that make many people make the wrong assumption about the meaning of the number. For Class A, the first octet, the first odd fact is that the range of values in the first octet omits the numbers 0 and 127. So you won't see 0 as a IP address, anything starting with a 0, and you won't see 127 because 127 is still reserved because of a special address used in software testing called the loopback address. And Class A network 0.0.0.0 was originally reserved for some broadcasting requirements. Now for Class B and C, some of the network numbers can look, if I could get that focused, can look odd, particularly if you fall into a habit of thinking that zeros at the end means the number is a network ID, and 255s at the end means it's a network broadcast address. So that can be a bit confusing. So the first Class B network numbers range from 128.0.0.0 to 191.255.0.0 for a total of 2 to the 14th power networks. However, even the very first lowest number, Class B network 128.0.0.0, looks a little like a Class A network number because it ends with 3 zeros. However, the first octet is 128, making it a Class B network with a 2 octet network part, which is 128.0. For another Class B example, the high end of the Class B range also might look a bit strange at first glance, 191.255.0.0, but this is indeed the numerically highest of the valid Class B network numbers. This network's broadcast address, 191 .255.255.255 might look a little bit like a Class A broadcast address because of the three 255s at the end, but it is indeed the broadcast address of a Class B network. Similarly to Class B networks, some of the valid Class C network numbers do look strange. For example, Class C network 192.0.0.0 looks a little like a Class A network because of the last three octets being 0. But because it is a Class C network, it consists of all addresses for that begin with 3 octet equal to 192.0.0. Similarly, 223.255.255.0, another valid Class C network, consists of all addresses that begin with 223.255.255. Okay, now these are some key facts for the CCNA exam. It states here, as with all areas of IP addressing and subnetting, you need to practice to be ready for the CCNA exam, and we should practice some while reading this chapter to make sure that we understand the procedures. So basically with the CCNA, they're going to rate us on, they'll rate on speed. So the goal here is speed. So if we do understand the IP address, class, network octets, host octets, network ID, network broadcast address, the goal is to practice and continuously being repetitive and continuously practice over and over to just gain the speed. So what we will be going over is practice deriving key facts based on IP address. And we will review, we will be going over this as far as review, IP address. Now the first one I did put in the class for each one. So if you have a moment, you could go ahead and input the numbers. Number 6, IP address is 200.1.9.8, and that is a Class C, because a Class C is 192 through 223, and that's a unicast, and it's used for small networks. Number 7, 192.0.0.1, that is a Class C, and the same as I just stated, unicast, small network, 192 through 223. Number 8 is 191.255.1.47, and that is a Class B, because a Class B is 128 through 191, which is a unicast, and is used for a medium-sized network. Number 9 is 223.223.0.1, and same as above, Class C is 192 to 223, unicast small network. So I would like to give you a few minutes to input the rest of the information, which is network octets, host octets, network ID, network broadcast address. So see if we can do those within the next minute. So what we do have here are the answers. So as you can see, the class number of network octets and number of host octets all require you to look at the first octet of the IP address to determine the class. Class A, 1 through 126. Class B, 128 through 191. Class C, 192 to 223. Class A address with 1 network and 3 host octets. Class B with 2 networks and 2 host octets. And Class C with 3 network octets and 1 host octet. So with these, the first octet of problem, we're going to start with problem 8. I don't want to go over 14 minutes on this video, or 15 maybe. So the first octet of problem 8, 191.255.1.1.47, sits up on the upper edge of Class B. Range for the first octet, 128 through 191. As such, to find the network ID, change the last 2 octets, host octets, to 0, which is what we've done. For a network ID of 192.255.0.0, this value sometimes gives people problems because they are used to thinking that 255 somehow means the number is a broadcast address. But this is not the case here, as you can see. The broadcast address found by changing the 2 host octets to 255 means that the broadcast address is 192.255.255.255. Okay, and let's go to the last one. With IP address 223.223.0.1 is near the high end of Class C range, 192 through 223. So as a result, only the last host octet is changed to 0 to form the network ID 223.223.0.0. It looks a little like a Class B network number at first glance, but because it ends in 2 octets of 0. However, it is indeed a Class C network ID based on all the values in the first octet. Okay, and now we will go over analyzing classical IPv4 networks, Chapter 12. Do I know this already? And number 1 states, which of the following are not valid Class A network IDs? Choose 2 answers. And it's a little tricky. You just got to focus on what they say specifically. And the 2 that are not is 130.0.0.0 and 127.0.0.0 is not one either, because 127, as we read, is not classful. Well, actually it is classful, but it's reserved for loopback addresses for studies. And number 2 is, which of the following are not valid Class B network IDs? And as you can see, all of these are valid Class B networks. Number 3. Get it focused. Okay. Which of the following are true about IP address 192.168.6.7's IP network? And they asked us to choose two, and the two answers are: the network ID is 192.168.6.0, and C, the default mask for the network is 255.255.255.0. And number 5, the last one: which of the following is a network broadcast address? Is it 10.1.255.255 or 192.168.255.1 or 224.1.1.255 or 172.30.255.255? And the answer is 172.30.255.255. Let me get that last one that I didn't get, number 3. Okay, so it states, which of the following are true about IP address 172.16.99.45's IP's network? And the truth is that the network is a Class B network. The number of host bits in the unsubnetted network is 16. Alrighty, and lastly, let's get down on cue cards or whatever is best to study from. Is that Class A is 1 through 126. It's a unicast and is used for large networks. A Class B, 128 through 199. The purpose is a unicast and it's a medium size network. And Class C is 192 through 223. It's a unicast as well, and it's for small networks. And Class D and E, you won't hear too much about. Class D is 224, and it's 224 through 239 multicast. That's the purpose, and we'll go over that a little bit later, the meaning of that. And Class E is 240 through 255, and it's reserved. Formerly known as experimental IP addresses. All right, so we done reached the 18th minute mark. I'm gonna go ahead and cut it short here. So we still have plenty more to discuss as far as the IPv4 networks. So I'll see you tomorrow, and I wish you well. Keep studying.